So yesterday we were looking at the electromagnetic spectrum. Okay, just let me remind you once again. So this is around radio waves, then microwave, IR, then visible, which is Web gap, then UV, then X-ray, then gamma. Okay, so sorry, this is infrared. Okay, so yesterday we mentioned here the wavelength is more, and as the electromagnetic spectrum goes, the wavelength reduces, so that wavelength is more, energy is less. Energy is less. Here the wavelength is less, energy is, sorry, undo is there? Yeah. Okay. So here the energy is more, so wavelength is less. So yesterday we learned about this. This is an electromagnetic spectrum, but what we are seeing around is the visible light, this part, visible light. Now let us understand this section, only the visible light. So how, I'll tell you how you can analyze. Yesterday I was shown you the CD. Yesterday I shown you the CD where you can see the 7 different colors, or the best example, natural example is your rainbow. Okay, so in lab what they do is they split the light. There is a this one called as prism structure. On triangle structure will come prism. It might be made of quartz. Okay, if light falls on this, any light, you can do, if you have a prism like structure or a diamond, okay, if you have, put a light onto that, if you just observe, it will spread into 7 colors. 7 colors. Or very simple way is, put that light on a grating. Actually this yesterday, that's why I showed that CD. The CD has the surface like this. If CD surface is this one, actually the CD surface is like this. So when light falls on this, here also the splitting takes place. 7 colors. So that is the 7 colors is the visible light. Okay. So now the visible light is that Vibgaya, that is violet, indigo, blue, green, yellow, orange, red. These are the colors. Okay. So if you want to analyze, it has a different wavelength and energies. If I make you to understand this, for example, yesterday also I gave the same example. If you give it for your blood test, okay, they study hemoglobin around 600 nanometer or 550, 560 nanometer. Or if you give some other test like ELISA for some typhoid or something, if they are doing, they study the color. It's around 600 nanometer or 580 nanometer. Like that, there are different nanometers for different color. Okay. So again, these colors, if you take the violet light, it is 380 Actually, Mataji told me to get the Xerox of this. I have written very badly. That's why I am writing here. Nightly you can copy it if you want. Yeah, right. Yeah. So 380 to 450 nanometer. Then 420 to 440 nanometer. Then 450, 495, and there will be overlappings. Okay, it is not like our it's not a scale cut or a knife cut. Overlappings will be there. Then 495 to 570, then 570, 590, then 590 to 620, 620, 750. Usually it is take 5. Actually that is 750. Okay, usually up to, okay, so 800 nanometer we take it. Here the nanometer means it is a measurement. Yeah, it's a measurement. Nanometer, meter we know. Okay, nano is 10 power 9 meters. 10 power minus 9, sorry, 10 power minus 9. So that many meters. So imagine the thinness of that wavelength. Okay, the nanometer is this. So if I want, yesterday Venkatesh sir has showed, if you are seeing blue means it is reflecting blue, it is accepting or absorbing all other colors. So that is what. If you are seeing blue means, okay, it is absorbing all other colors except the blue. It is reflecting the blue. If you are seeing white means it is reflecting all. It is reflecting all. It is not absorbing at all. Okay. If it is pitch black, pitch dark means it is absorbing all. It is not reflecting any. So any color, okay, any color, if it is, for example, plants, we see green because of the chlorophyll. Actually